So today we will be solving the problem number A from AtCoder Beginner Contest 43. So let us open the first problem. So the name of the problem is Children and Candies, and the problem statement says there are n children in AtCoder kindergarten. Mr. EV will arrange the children in a line, then give one candy to the first child. In the line, two candies to the second child, n candies to the nth child. How many candies will be necessary in total? And the constraints of n are from 1 to 100. So it is a very basic simulation problem as well, and you can also do it in constant time. I'll be sharing both the solutions. Since the constraints are from 1 to 100, we can write a brute force solution for this as well. So the brute force will be like we will run a loop from 1 to n, and we will be adding the number of candies that we are going to give to the ith child. And as mentioned in this question, the candies given to the ith child will be equal to I itself. So in each iteration, we will add the value of I itself to the answer. So let us quickly consider the input. The input is just the integer n. So let us come into the code and take the input. So I will take an integer n is equal to my input, and I will keep an integer answer to store the answer that I will generate after running the loop. I will run the loop from I equal to 1 to I is less than equal to n, I plus plus. And in each iteration, I will add the number of candies given to this child, which is also equal to I itself. So I'll be adding I to my answer. Once I have done that, I can print the answer. So let me run this and let me see what is the input given. The input is 3 and the output is 6. So let us test that out. We are gonna give an input of 3. Let us wait for it to compile, and the output is 6 as expected. Let us consider the second test case. For n equal to 10, the output is 55. So, and we are getting the desired output. For the last, for 1, the output is 1. So let us also try that out. And that works as well. So you can try submitting the solution. So let me just quickly copy from here, paste it here. And since the file name will be main.java, I need to change my class name to main. I need to hit submit. Now we can wait for the judge to give its verdict. And as you can see, the solution has passed and we have got the accepted verdict as well. But there is another solution for this question because it can also be modeled as a mathematical problem. So let me come here and let us discuss another way of solving this problem. So if I consider a test case of, let's say, n equal to 5, that is we are having 5 children standing in a line. Let us say that this array will denote the ith element of this array will denote the place of the ith child. Since they are standing in a line from 1 to n, these will be 1, 2, 3, 4, and 5. And the number of candies given to, to the ith child is also equal to I. So it will also be 1, 2, 3, 4, and 5. So let me just quickly label these. These are the positions of those children, and these are the candies given to each of them. So if I try to write this down for a general case, or for this case itself, the answer is going to be 1 plus 2 plus 3 plus 4 plus 5. And if I try to see this, it is not hard to see that if the ith child is getting x candies, then the I plus 1th child is going to get x plus 1 candies, because this is as mentioned in the problem and we're just trying to use that fact itself. So by this property we can say that the given summation, the given answer is following an AP. AP means an arithmetic progression whose first term is given by 1 and the common difference, first term is denoted by A naught and the common difference, that is denoted by D, which is also equal to the difference between the consecutive terms, is 1. So I'm not going to go into the depths of the proof of this formula, that is a summation up to the n terms of an arithmetic progression, which is given by n over 2 times twice of the first term of the series plus the number of terms minus 1 times the common difference. And you can try running the proof over the internet, but I'm just gonna say prove that this formula is correct by using an example here, which is of the summation of the first 5 terms. So n is equal to 5, so that will be 5 by 2 times twice of the first term, which is 1, as mentioned in this line. So twice of 1 plus the number of terms, which are 5, minus 1, the common difference, which is also 1. And I can get that this is 2.5 times 2 plus 4, which is going to be 2.5 times 6, which is 15. And if you try to run the sum for it, which is given by 1 plus 2 plus 3 plus 4 plus 5, you will get that this sum is also 15. So this formula works. Now I can also make this formula a bit more neat by putting the values of a0 and d. So s of n can be written as n over 2 times twice of a0, which is 1, plus n minus 1 times d, which is also 1. And after writing it out again, it can be written as n over 2 times 2 plus n minus 1, which can be written as n over 2 times n plus 1. And I can also just rearrange it a bit more to make it a bit more legible, and I can write it as n times n plus 1 over 2. So this is the summation over n terms of an arithmetic progression whose first value is 1 and the common difference is also 1. So and in the given question we are given the value of n, that is the number of terms that we have in this series, and we have to compute the summation up to n. That is, we have to compute the summation of the first n natural numbers. We can use our newly found formula, and we can put the values of n as which we have been given as input. So it will be n into n plus 1 over 2. So now with this set, let us try running this with the same inputs. It gives the same result, and for 10 we're getting the same result, and for 1 we're also getting the same result. So let us try submitting this code. So let me go into the question again, and I can come and I can paste this code here, change the name of the file, I'm in class because the file is going to be saved as main.extension. Okay, looks like I need to select the language and then I can submit. And we can see this also passes. So these are the two ways of solving this problem, but the difference being that this code works in constant time. So even if the constraints on n went up to 10 raised to the power 12 or 10 raised to the power 16 or 18 even, this code will work. But the other code that we wrote just before this will not work because it works in big of n. So the maximum constraint that it can handle would be of n going up to 10 raised to the power 5. So that's how I solved the problem number A of AtCoder beginner contest 43. If you have any doubts, leave them in the comment section. And if you want me to create a video on why the summation of the first n terms of an AP was given by that formula, let me know in the comments as well. I will create a video on that as well. So thanks for watching, and I will see you in the next video.